All right, so welcome everybody. So here's the name that takes your imagination to ancient empires like ancient Rome and ancient Greece, and you expect to see like pictures of maybe Trojan wars and I don't know what else. It will have nothing of that. The title is a complete lie. Instead, we will do something very practical and hopefully very useful. And we're going to talk about 3 different aspects of DevSecOps, which might not be trivial for the average Joe software engineer that heard something about DevSecOps, knows the importance of security, but maybe not up to think about interesting twists that might present a very big problem to the point of empire failures and very big companies finding themselves in very deep shit because they didn't pay attention. So it will be very embarrassing if all of you already thought about everything that we are going to talk about. And that will be obvious, if that's the case, very, very soon, because I will ask you a number of questions. So, questions from your lawyer that I'm sure you see every day in your corporate environment. And questions might be, for example, who is not paying attention to licenses? Who knows not paying attention to licenses is trouble? Who knows that if you don't pay attention to open source licenses, your company will be in trouble? Everybody knows that. Perfect. Great. Thank you very much. Who has an open source licenses list which is distributed with their software every release? You said it's important. What's up? Okay, you're in the right place. Awesome. Good. Okay. Let's say someday someone will ask you for that list that you don't have. Do you know how to start going about it? Who knows how to collect open source licenses in their product? Okay, you just don't do it because who cares? This is how empires fail. I have to remind you. Okay, who actually does continuous governance of open source licenses in their organization? JFrog people, which makes me and our lawyer very happy, but probably no one else. You are in the right place. And I don't know how frequently you have those conversations with your lawyer. Based on your answers, not very frequent. We have this conversation with our lawyer now. So let me introduce to the stage Eyal Ben David, JFrog's general counsel. He is a real lawyer. And
hey everyone.
Okay, extra bonus question. How many people saw a lawyer on stage on a software conference?
In a t-shirt.
In a t-shirt. Hands down, no one ever saw a lawyer in a t-shirt. So Eyal, thank you for joining us and thank you for the opportunity to provide this view of a lawyer for us software engineers and tell us what you care about when it comes to open source governance in a startup or any technical conference.
Happy to do it, and hi everyone. But Baruch, we were going to start with a lawyer joke. You skipped that.
Yeah, where did you find your lawyer?
Where's the lawyer joke?
Where did I find my lawyer?
But good.
Obviously,
I'm glad we did skip it.
In the bottom of the sea. People know this joke. People know this joke, really.
For sure. All right, so hello everyone. My name's Eyal. I'm the GC at JFrog. I promise it's 5 o'clock on a Tuesday.
GC stands for garbage collector.
Oh, there you go. There it is. You came up with that just now. Nice. I know it's 5 o'clock on a Tuesday, and I promise not to dive into any deep legal concepts, but we are going to talk a little bit about software licensing, specifically open source software.
Yes, absolutely.
A little bit about my world of where legal meets tech meets business and how that intersection is relevant to this when empires fall. So to follow up on Baruch's questions, how many of you work for a company corporation that has a policy defining what open source you can use, what you can't use in creating your proprietary software.
So we know you don't update it. How many of you are aware that it exists?
Nice. All right, about half. My follow-up question is, how many of you have opened that policy in the past month? None. There we go. All right, so a little view into my world, and we were thinking about what would be interesting, and there's many different examples that we can give of where it becomes relevant and why it's relevant, but we wanted to talk about M&A. M&A transactions, something that we like to read about.
People know what M&A is?
Oh, I'm sorry, mergers and acquisitions. I think they all do. Yes, I see everyone's nodding. All right. When we at JFrog, or in general, when companies look at a target for an M&A, for an acquisition or a merger, one of the first things we're going to look at and ask for is that list of open source components, the thing that Baruch mentioned before that we weren't sure that everyone has. The reason we're going to look at it is mainly IP ownership, right? The main thing we want to determine is this company that we want to buy, is this software that we want to acquire, do they own it? Now, the question of own isn't always a yes or no question. We want to see if there's any third parties that may have any claims on that IP, if anyone's going to come back and ask for royalties, if anyone's going to have any questions regarding that ownership if we buy it later, and how are we going to be able to make money off that software moving forward to do with it as we wish.
So what is the problem? So, okay, so I have an awesome startup and you're mighty JFrog want to buy my company. What can go wrong?
Well, let's talk about some examples, Baruch. Let's talk about some examples of when that can come into play, when our IP ownership couldn't be relevant. Let's think of some examples from the press that we saw in the past few weeks.
Yeah, you know what? So first of all, I think we actually, as JFrog, we had this experience when some transaction actually failed on IP ownership.
We did, and we've looked at different transactions over the years. We've looked at different companies, and it's not the one thing that that you'll say yes or no to a transaction for, but it's something material that you look at. We'll look at that IP ownership, see if there's any copyleft licenses, any ownership issues.
What are copyleft licenses?
What are copyleft licenses? Let's ask around. Are everyone familiar with the term copyleft licenses? Really, in a nutshell, a copyleft license is a license similar to the GPL. It could be a reciprocal license, meaning if we use it inside our proprietary code, we may have to share that code back to the world. We may
what we call a viral license.
A viral license.
So
exactly.
if we use a GPL, we are essentially GPL, regardless what we want to think of ourselves.
In certain situations, and let's talk about that. So let's talk about the LGPL.
Oh, LGPL. Who heard about LGPL? Who knows the difference about GPL and LGPL? Perfect. No one knows. Yeah, Idan knows. Yossi knows.
Idan knows the difference.
Yeah.
Nice.
So LGPL is a license which was supposed to make GPL less viral. And it's like many years ago, they made this difference between static binding and dynamic binding. Correct. For languages like C, C++. And they say if you statically bind, if you compile our source with your source, your code is now open source. That's the viral part. But the L lesser comes to say, but if you only do the binding dynamically in runtime, then it's not a big deal. Then you don't have to open the source for us.
So, Baruch, can I use LGPL in my proprietary software?
That's a great question, because this is exciting how the technology changes the meaning of a legal document. LGPL was written with terms that made sense for a certain technological stack in mind, C, C++. Then came Java. In Java, do we have static binding in Java? Everything is dynamically binding, and suddenly LGPL is a completely safe license. There is no static binding, there is no viral, let's all use LGPL. But then Go came. How dependencies in Go work? It's all static. We always compile together. So suddenly the same LGPL who looked absolutely safe for us Java people now is absolutely open source viral. It's like it's changed its meaning 180% because we use a different programming language. That's super cool and obviously super scary.
Indeed, and one thing we would suggest is that policy that we discussed is not something that we can write, throw in the drawer, and not look at ever. It's something that has to be dynamic and has to evolve along with the technology, and something we should properly revisit, study, and teach on an ongoing basis.
So you should see your lawyer more.
Should see your lawyer more. There you go. Let's talk about some other examples. Baruch. Another question for the crowd. If there's a project or a library on GitHub with no license, That's maybe an easy question. I've asked about 20 people the past few days, and I got a wide variety of answers. Can I take that library and use it in my proprietary software? Who says yes? You technically can,
Are
true.
you allowed to?
Are you allowed to? So, good. I see the answer is pretty commonly no, and it's obviously clear that if we take that without a license, we're using someone else's copyright work, which we then will have that IP ownership question that we discussed earlier.
And people do that, Kolesman. People do it all the time.
Yep.
And the real question is, it's think about yourself. You found a library on GitHub. Will you check the license? Who will check the license? No one will check the license. So yeah, please.
We see a few.
That.
We see a few, and they're mostly from JFrog.
Yeah. Well, that's all the old JFrog people. You train them well. So why? You know what? Ridiculous examples. A code that someone put as a background on their LinkedIn header. You know, in LinkedIn you have your header, which is like a white picture. Someone took some kind of code, put them there just for illustration. Next thing you know, it's in someone else's product.
If you guys read the papers today, that was one of the items.
So stop treating code as it's not important who it belongs to, because it is important.
Let's talk about another fun example.
Yeah.
A blog you wrote a couple years ago, or maybe a little less, but a couple years ago, a company named Lerna, or a product named Lerna.
Yeah, it's an open source project and was like a year ago. Yeah. Who heard about the Lerna incident? Oh, you didn't.
He done again. He's number one student.
You are here for a treat. It's one of the best stories I ever learned about licenses.
Agreed.
Go ahead.
Agreed. So Lerna, an open source project distributed under MIT a couple years ago for political reasons that we definitely don't want to get into if they're right or wrong, released a version with an MIT license with a tailored MIT license, calling out certain enterprises by name and certain corporations that they were not allowed to use that license or that library within their software. Now, if you can do this, if you can't do this, if it's legal or illegal, if it applies or not, that's a question for later, and we're happy to discuss. But for today, the point that we wanted to make is we, as a company, we want to know that this license has changed. We want to at least have the conversation, as Baruch says. You want to go talk to your lawyer and make an educated decision on if you want to keep on using that library in your software. It may or may not harm you later down the line.
Now, there is a caveat. Not only they changed this license, they did their best to do it in the most sneaky way. So how many of you are familiar with SEMVer, semantic versioning? Oh, majority of you. And you know how semantic versioning works. So a major version breaks, right? You expect a license change that will disallow usage of your library for some companies will be a major version, right? Because we want, if we use now a certain version, version X, before we update to Y, this is a conscious decision. We see what changes, we check the release notes. One of the items in the release notes is license change. You cannot use it anymore. And we're like, fine, we will stay on version X, or we will use an alternative tool, maybe fork, whatever. Now, what about the patch version? Most of the dependency managers will download a patch version without asking you. It will be automatically updated. If they manage to change the license in the patch version, all those companies that were called out as not allowed to use this software will be in breach of license without anyone in the company knowing that that happened. I have goosebumps up till today when I think about it. Because this is how you take a huge corporation, starting with M and ending with Microsoft, down. This is how you do it. It was evil genius, but think about it. You can be in this place like any day.
Now, Baruch, that example is good with two MIT licenses. What would have happened if they switched from MIT to GPL? Then it could be even more detrimental.
Absolutely.
Exactly the point.
Yeah,
exactly the point.
yeah.
So I think what we're getting at, and I think that the point is that we have two main key core advices that we want to give, or two key practices that we need to follow. First thing is we need a policy. We need a policy that we learn, we study, we practice we visit every day, hopefully. And the second one is to actually use that policy and make our users aware of what open source components and libraries we have in our software.
It should be continuous. The license government should be continuous as your continuous integration, continuous delivery, continuous security. Continuous license government is the part of that. And the customer or the stakeholder that dictates how this governance happening is right here. This is your lawyer, this is your counselor, that you will ask, okay, Eyal, tell me what I'm allowed to use or not allowed to use, and I will bake it into my pipeline and make sure that we are not in breach from the rules that you tell us which are right and wrong. And those rules are completely dynamic from company to company. For one day, I might wake up in the morning and say, you know what? We will never use any licenses from our competitors because there is some danger that they will try to fuck us over. Sorry, I didn't
Not sure
mean
I'd
to
say that. Yeah.
Yeah, no, that was no. But and then let's not use any of those, right? We need on the same day come to work, impose those rules, and make sure this will never happen again. So let's do a demo.
Let's do it.
And you will tell me what I need, and I will do that.
Let's do it.
All right. So this is my okay. There is a tool for that you don't see, but you will in a second, and it's called. Anyone knows? Brian knows, but he was in a rehearsal, so it doesn't count. JFrog X-Ray! Surprise?
Woo!
Woo! Yeah. So you might have heard about JFrog X-Ray as a security analysis tool, and we're going to talk about this aspect of X-Ray in a second, but it also has the same principles of continuous security as continuous license governance. So you can set up a policy which is usually or by default, you might consider a security policy, but also you might set up a license policy. So that will be a license compliance. It's a good name for a license compliance policy, I think. And the way it works is I want it to be of a type of a license, and I will define rules that Eyal will define for me. And he will say like a blacklist, a license blacklist or something, right? That's my rule. That's what we want to say, and we want to ban licenses. And again, Eyal gave me the list, and one of the lists is let's say don't use C. What was the name? CPAL. What was the name? Forget the license I need to ban. Great. No, something. Oh my God, sorry about that. I blacked out for a second. I know where to check in Artifactory or in X-Ray. In X-Ray. No, I can check it in X-Ray. So discard. I will do it once again in a sec. And JUnit. It's a license that JUnit carries, and JUnit, I don't want to use JUnit in production, obviously, right? And one of those can be don't use CPAL1. Here you go. I want to ban this license because I don't want to use in production licenses from tests. So I will create a new policy, and now you remember it very good because I did it twice. And that will be license, and we will define a rule, and that will be banned licenses, and we will do ban licenses, and that will be CPAL. Here we go, CPAL. This guy. Oh, and also, I don't want any unknown licenses because I don't know if they are good or not. I will prefer to stay away until I get clearance from Eyal. Okay, so this is good. And now, I didn't do anything. And now I can set up, not discard, save. Sorry, long day. And now I can define watch. And I can say, I want to watch, name for a watch, what's a good name for a watch? Night Watch. Well, not so good. We don't have Night Watch anymore, so let's do License Watch, because Night Watch is not a thing anymore. So what we want to do is we want to watch all the builds that go through the pipelines. Continuous license compliance. Every build I wanna watch, and now all builds. And now I want to attach the policy, which will be my banned licenses policy. The internet is a little bit slow, but not horribly slow. License compliance, that's my thing. All right, and now I'm done, and let's try to build something that has JUnit as a dependency. So that's my Jenkins, and it has this build, and I'm going to say I want X-ray scan, and I want my build to fail, and now in 22 seconds, more or less, we will see how the build fails. So I started it, and that's the blog. So it builds, obviously, that's what takes the longest. And now downloads the stuff, downloads the internet, obviously from Artifactory. Boom, it failed. It failed. Yeah, that's a good failing demo, Shlomi, thank you. And it actually failed because I didn't configure something right, but in a really failing demo, that will fail on security vulnerabilities. That's a meta failing demo. I managed to fail a demo that was supposed to fail.
Supposed to fail.
Yeah, no, but I apologize. It was a long day. I won't rerun it again, but I think you got the gist how it was supposed to work. So this is it, and this is how you bake your license compliance into your continuous pipelines, right? So with that, let's talk about something else. That was the compliance part that apparently you didn't think about, so you are going to start think about now. Now, continuous security, on the other hand, this is something which is constantly on your mind. You are sitting in a DevSecOps track. That means you are security conscious people. You know that security is important, right? Okay, who uses Docker? Everybody uses Docker, great. Who scans Docker with security tool? Okay, this is disturbing. I would still expect everybody to do that, but apparently you're in the right place. Okay, so when you pick a security tool, everybody have this checkbox, we do security image scanning. What does it mean? And whether it will find a vulnerability inside a proprietary application binary on any of the layer deep of your Docker image, this is something that you won't find on those shiny, like booklets that you get in conference for your next security Docker scanning tool. And to tell you a little bit about why it is important, I want to invite the person who was there during our work to support 24 different package types in Artifactory, and he was there through all of the 24. Yossi Shaul, senior architect at the CTO office at JFrog. Woohoo!
Thank you, Baruch. So before we start, let me explain what does it mean scanning a Docker image. So Docker image is usually built upon some kind of Linux distribution, and those distributions are bundled usually with several components, sometimes a lot of different components. So when we are talking about scanning a Docker image, basically it boils down to opening the various layers inside the Docker image, fetching the list of installed OS level components like the RPM files, Debian files, and comparing it against vulnerabilities database. That's what it means. And as Baruch mentioned earlier, a lot of companies knows how to do it. We also know how to do it. Is it an important thing to do? What do you think? It is.
It will actually catch the next Heartbleed, right?
Yeah.
Because Heartbleed, if you remember, that's what it was. It was a system level binary inside your Docker image.
Yeah, true. So it is an important step to do. Everyone who uses a Docker image should do it. So it's no wonder that all of the companies around scanning Docker images popped out in the last couple of years, and everybody is trying to provide this kind of service. But
I have a question for you, Yossi.
okay,
If you have, okay, so what you actually did, you went through the operating system in Docker, took every binary that installed there, got its checksum or ID in some way, went to an external database, compared if it's there, and reported if it's safe or not.
right.
Right. Now, I have my own application, which I added to my Docker image. Obviously, the checksum of my own application won't appear in any of public databases, at least I hope so, right? Because no one knows about it. It's my application. It does something very unique to me, and no one else in the world knows it. So how this tool will help?
So it won't help in this case. Okay, so you mentioned Heartbleed, for instance. Heartbleed was a vulnerability in OpenSSL library that is installed in mostly every Linux distribution, and a scanning of Docker image will find it.
Exactly.
But let's take, for example, another famous or infamous data breach, Equifax. Anyone heard about it? Okay,
Yeah,
very famous
I mean-
one. But it's not unique. Okay, it was famous because it was huge, a company that almost everyone knows about, and it was a shame that it happened. Okay, but this kind
You
of
don't
vulnerability.
care, you're in Israel. But we got the blow.
So this kind of vulnerability is a vulnerability inside a proprietary application that is packaged in a specific packaging. In this case, it was probably it's a Java application. It's probably a WAR file, and a simple scanning of a Docker image will not find this vulnerability. So in order to find vulnerabilities of third-party components, whether in the Java world or NuGet or Python or NPM or plenty other technologies that you have, you need to do something else. And this something else is what we do in X-Ray. It's a deep analysis and deep scanning of all the components that we can find inside a Docker image or any other technology for that matter. Okay, so what we basically do, we take the Docker image, we scan for the basic OS level vulnerabilities like everyone else does. We have our own extensive database, we compare, and then we move on to the next stage. The next stage is scanning everything on the file system and trying to find out whether it's a component that we identify, and if it is, we match it against our own database. And we also do another thing. We also perform a deep scanning. Okay, in a lot of cases, I mentioned it's a proprietary application. We support multiple languages. It means that it might be a zip, it might be a tarball, it might just be a directory inside the Docker image. Okay, so we need to scan all of those files, and if we find an archive, we know how to open it and do recursive and deep scanning inside those archives. And for every file, we calculate the signature and try to compare it against a well-known vulnerabilities database. And this kind of scanning is something that you can use to find vulnerabilities in a third-party components, and a lot of them.
And obviously, it comes with a responsibility on our side to support as many technologies that are there, because that will be the difference between a useful tool and not so useful tool. So let's say, how many of you use Java? Okay, what, like half of you? How many of you use JavaScript? Here we go, so we need to support at least 2 of those. How about Go? Any like cloud native people? Cool. So we need to support Go. How about NuGet, .NET? here we go, we need to support that as well. So you got the gist. If we don't support any of that, your next struts 2 that will make an Equifax out of you can be in this language that we don't support, and we betrayed your trust, and your empire failed. So let me show you how this deep scanning works. You don't go anywhere yet.
Sure.
And again, back to our X-ray. So I won't try build because that's apparently not my strong suit. Instead, we will look at an existing build that I run in a quiet environment before the talk. So it actually did what it has to do, and it failed as it's supposed to fail. And that was a Docker app. Now, a Docker app is a Docker image that has inside a WAR file, and that's a completely proprietary WAR file. This checksum not exists in any database, but inside we have, inside a WAR file, there is a lib folder in which all the vulnerabilities reside. And we see that this app definitely has a problem. And when we dive deep into it, we can see that we have 134 vulnerabilities, which is probably shouldn't go to production anytime soon. And look at that. So did I click it? Did I? There we go. Right? So what you see here, now it will open all my clicks, obviously. And that's a resolution that we cannot support. Here we go. So look what's going on here. We have, it's just a bad technology day for me. Okay, so we have here a Struts2 vulnerability. That's the same Struts2 that Yossi spoke about as we rehearsed it before, and he knew that I'm going to show it. It's in the SwampUp WAR. SwampUp is just around the WAR. It's not in any database, which is inside the Docker layer, and now it disappeared completely, which is inside the Docker image. So here it is, SwampUp WAR, and that's a SwampUp WAR that has 76 vulnerabilities. The rest of them are actually in the Docker layer, and they were found by X-ray as well. And you can see here the Struts2 vulnerability inside the Struts file, right? So here it is. It's just inside the SwampUp. So this recursive scanning can be, that was like 4 layers deep. It can be any depth with any mix of technologies. If we wanted to wrap this WAR file in a Debian package to install it like maybe once inside a Docker image and once like on a bare metal, that would work as well. We will just have one more step in this bullseye that goes even deeper, right? But I do have a question for you. Equifax, they are not malicious, right? They didn't do it on purpose. Probably when they start to use Struts2, the vulnerability that eventually was used to attack them wasn't even known. Right. And they might even check their builds for known vulnerabilities, but what they had in production is lost, gone from the pipelines. It's already in production. How can we solve this problem?
Okay, that's a good point, and it's actually true. So even if they use a scanning tool, you scan something, at the moment you scan it, it might not have any known vulnerabilities, and it happens all the time.
Of course.
Okay? Requesting or asking rescan of everything from scratch is not practical. Okay, why not? Because we are talking about terabytes or even petabytes of data, and trying to scan it every time we find a new vulnerability is not practical. Okay, so what we did and what we have in X-ray is something we call an impact analysis. Impact analysis is basically the ability to answer at any point in time a simple question. What if? What if is specific vulnerability has a specific component has a vulnerability, or change license for that matter? Okay, and you can get an answer. Okay, which of your file in the organization, which applications, which Docker images will be affected by this component vulnerability. Okay, how do we do that? Basically what we do is, I mentioned that X-ray knows how to scan, and it does recursive scanning, and while it does it, it builds a graph. It's a graph of all the components, okay, with a parent and the children, where the children might be another application that has another application inside, down to the lists of components. Okay, we take this graph and we save it in the database. So how do we use it? Later on, when a new vulnerability is discovered, it's reported. It might be from the vulnerability that Brian will talk about in a minute. This vulnerability will eventually arrive to the X-ray database, okay? And shortly after you have it in the X-ray database, what X-ray does is it's taking the vulnerabilities, it's checking what are the signatures that might be affected from these vulnerabilities, taking all those signatures and checking now in the components graph. Do we have those signatures anywhere inside our organization? And if the answer is true, it will calculate all the paths back to the root files. Again, root files might be applications, they might be Docker images. It will create a report and send it to you with alerts, with all the information of what was the trigger for the vulnerability, what are the affected components that you actually use with the vulnerability, and if there's a mitigation, also recommendations about those mitigations.
And here's an example of impact analysis. Let's say you learn now about Struts 2, you come to work on Monday, and you ask, whoa, this Struts 2 thing is bad, do I have it? Now you search it, and you find the Struts 2 vulnerable Struts 2 version, and you're like, oh my god, it's in a lot of files. But maybe they're like just lying around, I didn't deploy them anywhere. Let's see, I just picked one of them. Okay, they were part of a WAR file, part of a web application, and they are part of a Docker layer, and also a build. But maybe this is just, you know, an off-run Docker layer. Maybe no one actually uses it. Let's see if someone uses it. Yeah, okay. It was a part of a Docker image, which was latest, but also 62. But you know what? Maybe this Docker image didn't go anywhere. So we can go and look at this component and see if it was really used, because X-ray sits on top of Artifactory, which is your pipeline all the way to production. So you know exactly in which point of time where this Docker image was. And here you can say, okay, this Docker image was in bunch of repositories, and one of them is production. And this is where you go, Houston, we have a problem. And that's your impact analysis.
True.
So, Yossi, thank you very much.
Thank you, Baruch.
And now, when you know how your how license compliance can follow your empire, how not smart enough security even baked into your process can follow your empire, let's talk about, as always in life, quality above quantity, right? Bunch of questions. Who thinks NVD is a good, reliable, and basically enough database of vulnerabilities? Okay, who knows what NVD?
What's NVD?
Exactly. Who knows what NVD is? Okay, National Vulnerability Database. It's a governed and run database that contains vulnerabilities. And for a landman like me, sounds like, you know, government database should be good. What can go wrong? Equifax, by the way. CVE, which is kind of the golden standard in defining vulnerabilities. When you talk about vulnerability, what's the CVE number? If it doesn't have a CVE, it does not exist. The only point of truth for databases is CVE, right? And then that's a stupid question. Who thinks the bigger database of vulnerability you have, the better? Yes, that's the right answer. Yes, the bigger event, the better. Okay, to talk a little bit about the quality of your database, but also the quantity of your database, I want to invite a person who you already met in this morning's keynote, Brian Martin, VP of Vulnerability Intelligence with risk-based security.
Thank you, Baruch.
And I don't know a better person to talk to you about the database vulnerabilities database quality than the person that does this for fun for how many years?
Since '93, yeah.
We all have hobbies. This guy collects vulnerabilities.
I did it as a hobby for a long time, and then for work, and then as a hobby all along, and now it's kind of both. So yeah.
So why NVD is not enough? Why CVE shouldn't be a golden standard, and why sometimes quality is not less important than quantity, which is important by itself?
Right, so there's an old line, we're from the government, we're here to help, and it's kind of a, yeah, thanks, but no. So real quick, on the whole ecosystem, CVE and NVD are essentially the same. There's 100% overlap. You won't find a vulnerability in one that's not in the other. The only thing that really happens is MITRE, who runs the CVE side, will do the assignment, and then they kick the data over to NVD. NVD will then analyze it, and by that I mean they will generate CPE, Common Platform Enumeration, which is designed to make it so that you can automate the process to take those vulnerabilities and work it into your system, and assign a CVSS score, Common Vulnerability, whatever. Score, yeah. I shouldn't laugh. We actually give a lot of input to the CVSS SIG and everything, but and they do a score in version 2 and version 3. They sound the same, but in reality, those scores can be very, very different for the same vulnerability. In V2, it might come out as a 4.3. In V3, that same vulnerability might be a 7.8 or something. And so there's a lot of confusion around that as well. So now that you know about the whole ecosystem, the biggest flaw, and I mentioned some of this earlier, is that CVE doesn't take a proactive approach. They want all of you to go to them and say, I found a vulnerability, I need an ID, here's the information, let me write the description for you. And if you do all of that, and they're in a good mood, then they will publish the ID, if they don't forget. And by that I mean up to 10 years that they sometimes forget. That's not a joke.
That's scary.
It is. And so that's where us taking a very different approach to it.
How it's different? What do you do
right, so
differently?
we go out. We have 3,100 sources we monitor right now. In the next year or two, that will be over 6,000. We already have 3,000 more lined up. We just need to get them in the rotation, build out the team a little more. But we have to prioritize that based on what our customers say. You use this library, you use that library, fine. We want to take those first. Then we'll kind of go out and do the more obscure esoteric stuff. And so by going out and looking for these resources, we're able to find a lot more. And I spend about 60% of my life in bug trackers. If you have a public bug tracker, I have probably been all through it. It's my favorite thing in the world. Select all products, search, vulnerable, or vulnerability, or security, or exploit. And now I've got a full list of all the bugs or the vulnerabilities that have been reported against your products. Put them in our database, you know. And even if they're old, it doesn't matter to me. I want to see that whole picture. You're gonna, pick a new library. You have 2 choices. It's important for you to be able to say, okay, what does this look like for a 15-year history? Well, his library has 100 vulnerabilities, which sounds really bad. His library has 20, which sounds really good, except for it takes him an average of 4 days to fix them. It takes him an average of 4 years to fix them. So all of a sudden, all of a sudden that becomes a very different a view into that library for you to determine, well, wait a minute, if we're pushing out 20 builds a day, we want his library because we're going to wait 4 days at the most. What? I'm getting a red light back there. So anyway, yes.
I think the most important question that I felt kind of that was supposed to be asked during the keynote, so you have the opportunity to get the answer now. How do I buy it? Who should I pay to get this superior database for vulnerabilities?
So this is where a bunch of frogs are absolutely crazy, and they embraced my model of sales, and I'm not a salesperson. They just gave it to you already. It's already been an X-ray all along. There's no extra software module. There's no extra fee. It's just, hey, it's the right thing to do. And that's really one of the things that we're excited about JFrog is they have that same mentality. I want my data in every organization. I don't care what kind of money I get out of it. I'm weird like that. And then we also like them because their due diligence against us was insane, and their level of expectations against us is the same that we have for ourselves. So we saw it as just a great partnership as far as the mindset and how we approach this.
So thank you very much, Brian. And I wanted to summarize in one sentence what we saw. So basically, the most important problem is, I know the time's up, the most important problem is not paying attention. So Eli, I'm not paying attention to you, and that's the least of my problems. The bigger problems are when you don't pay attention for your license compliance, when you don't pay attention to the details of what your security tool can do, and when you don't pay attention for the quality of your database. This is how empires fail. With that, two householding items. First, the closing remarks. You remember? The restrooms? No. First of all, there are keynotes, feedbacks on your table, feedback cards. Put 5 in like every checkbox and you're done. Number 2, you have a unique opportunity to ask questions. Those 3 external gentlemen, especially the lawyer, you don't get a free consultation every day. Now you have 25 minutes with him for free. And that will be upstairs in the discussion zones, and we all are going to go there now. So come with us. It will be fun discussion. Brian will be able to finish his what he wanted to say.
He'll answer stuff about car insurance or anything you need.
He's good in everything. Thank you.